right, so we'll start with the angle bisector. So today is Friday, September 9th, 2022. So even though it says unit 1, day 4, it's really unit 1B, day 3. Angle bisector, so basically it's a line that's like right in the middle. And it's going to basically split your bigger angle into exactly two smaller angles. So somebody give me a number, any number that comes to your mind. 3, okay. So for instance, this angle measure, how about this? I'll say 33. Let's say if that angle measures 33, but we'll start. So that's how we're going to use the 3. Then this angle measure right here is also going to be 33. So your angle bisector, which is going to be this line right in the middle, there's your angle bisector. That's going to be the line that's going to split your two bigger angles. I'll highlight it. No, actually, let me use blue. There we go. There's your angle bisector. The blue line splits your bigger angle into exactly two congruent smaller angles. And we talked about last time, congruent angles, we notice, have that little arc, that single arc, or maybe the double arc. I think we talked about it. You might have left right before, but I do have it recorded in Schoology just in case, but I'm going to talk about it again. So again, your angle bisector splits your bigger angle into exactly two smaller angles. And also, your arcs are that's your big clue to tell you, oh, this angle right here is congruent to that angle. So I'm going to add that little tidbit in there. So arcs indicate congruent angles. So this was from last time. We had to talk about this, so I'm just going to reiterate it. All right. Questions so far about angle bisector? So again, this blue line, that's your angle bisector. I'm actually going to draw an arrow to the blue line. There you go. That's an example of your angle bisector. All right. Next thing, complementary angles. Sum of the two angles is 90 degrees. So, give you an example. Let's say on my first angle, let's say if this is 60 degrees, then what must my other angle measure in order to get a grand total of 90? So 60 plus what is going to give me 90? 30 degrees, very good. Oops. $60 plus 30 is 90. So yeah, in general, the sum of your two angles, and I'll just say in general, angle 1 plus angle 2 equals 90. That's your general rule. Questions? And then similarly, supplementary angles. Rather than 90, they add up to 180 degrees. So let's say if I had an angle that was 125 degrees. How many degrees must my other angle be to get 180? So final result is 180. I started with 125. How many more degrees do we need to get 180? How much? Careful. A little too high. Now 65. What were you going to say? 55. Because a lot of us, we went 180 minus 120. That's where we got the 6. But it's really, remember, 0 minus 5 can't do. So it's going to be 55. Again, this is your general rule. For some of your two angles, add up to 180. And these are going to be ideas we're going to be dealing with for quite a bit this unit. All right, next thing we're going to talk about, adjacent angles. They are side by side. They have a common side and a common vertex. You're like, what does that mean, Mr. Connors? Here's what that means. Let's say, here's one of your angles. And I'm going to have another angle right here. So let's say, somebody give me 4 letters. Anybody, any 4 letters that come to your mind, raise your hand. A-L-M? All right, K. And I need one more after the M. L-M, what else? J. Okay, so here's what we have. See this first angle, KJL? Angle KJL and angle LJM, those are our adjacent angles. Angle KJL and angle LJM. They are adjacent angles. These are adjacent angles, so I'll just put it right here. So if you look, there we go. Again, your common side. Look at the two. What 2 letters do we see in both KJL, LJM? What 2 letters do we see for both of these angles? And J and what else? J and L. There you go. That's how you know they're adjacent. They have same at least 2 letters in common. And one of them's the endpoint. But again, with the endpoint or the vertex, what letter do we see in the middle for both cases? Yes, that's important. Your vertex is the same. See the J there? You see the J there. That's very important. Your common side was J and L. There's your common side. There's your vertex. And again, the vertex, turning point, should always be in the middle. Always, no exceptions. So, vertex is your turning point. So I'm just going to add that in real quick. So vertex is turning point. All right. So next thing we're gonna talk about linear pair. So linear pair, that's a pair of adjacent angles whose non-common sides are opposite rays. So basically, I'll just, rather than talking, you're like, okay, what does he mean by this? Here's what we mean by a linear pair. Have an intersection. Oh, I forgot my arrows. So, and then I'll just use numbers for now. 1, 2, 3, 4. Pair of adjacent angles whose non-common side. So basically, all right, I'll give you an example. I'll give you an example. Somebody, anybody. All right, what number? Somebody give me a number. 1, 2, 3, or 4. Somebody start with a number. Somebody said 4. Who said it? Okay, thank you, Brooklyn. So, example, angle 4 and angle. So,
Forgotten to
no
put
worries.
it here. It's not.
Okay, no problem. So, besides angle 4, which other angle shares a side but it touches angle 4? Careful. Okay, we're going to talk about angle 4 and angle 2's relationship momentarily. 1, angle 4 and angle 1, because they have the same side. So 2 and 4, they're not going to have the same side, but they have another relationship though. So hang tight. 2 and 4 have another relationship. So angle 4, angle 1, because they both share a side. So 4 and 1, boom. They share a side. What could also be a possible option for 4? 3, yeah, 4 and 3. You could have had 4 and 3 in that conversation as well. Good. So adjacent means it's going to be next to. However, the last example, we talk about the vertical angles. This, Amy, with 2 and 4, they're vertical. That's their relationship. So I didn't want us to throw away your thought because you had a good thought too. So yeah, if we had same diagram. So it's 1, 2, 3, 4. Then you could say that's an example of vertical angles. 2 and 4. Angles 2 and 4. What could be the other possible vertical angle pair besides 2 and 4? 1 and 3. Angles 1 and 3. Good. All right. Question. Angles 2 and 4. Angles 1 and 3. Those are vertical. They're opposites from each other. They're going to be directly across. So it was unlike the previous example, 4 and 1, they touch, 4 and 3. Yeah, they're going to be across. All right. Now, couple quick things involving a linear pair. In fact, I realized I should have switched these two. But basically with a linear pair, if you notice the linear pair, or I'll give you another example. Your linear pair, let's say you had a line going across. And then, let's say there, or actually, even if we did it like this, your linear pair will still form a straight line angle. So notice, let's say this is 1, 2, 3. It's going to be a little different, but the idea is the same.
So even if it's like crooked, like the same idea?
Yeah, so as long as, yeah. So if they have that same, they share that side, you're still going to have a linear pair. So no matter what. So yeah, I know that was a little crooked, but it still works. Your linear pair, you still have your linear pair. Like for instance, 1 and 2, they're gonna form that straight line angle. Or 1 and 3, they'll form the straight line. 2 and 4, 3 and 4. So that would be your example. So in fact, so yeah, examples. Yeah, there's multiple examples. Angles 1 and 2. Angles 1 and 3. And then, but not 1 and 4. Or angles 2 and 4. 2 and 4, this case. So, and again, you don't have to write all the examples. And then again, with supplementary, what? It's earlier in our notes. How many total degrees is supplementary? Look up at the top of your notes from today. How many degrees? 180. Supplementary is 180. Good. It's 180. Exactly. And then this last example, again, I think next year I'm going to flip these two rows with the vertical angles. So like say they met at an intersection. They met at an intersection like this. Then same thing. So you know how we had 2 and 4? They were vertical angles. They're going to be congruent. Same thing with 1 and 3. They too will be congruent. And then sometimes you'll know, you might see that arc. Or I think we talked about it briefly. You might have that double arc. Boom, boom. Well, I'm not going to put the double arc in for now, but yeah. So vertical angles. Same thing. 2 and 4, 1 and 3. So far, any questions? All right. So now we're going to practice this a little bit on the next page. First, we're going to do it, the top two are going to be just numbers. But then the bottom, we're going to talk about names. And then we're also going to learn some tricks on how to fill in our diagram. All right, any questions before we move on? All right. So here we go. We go to the next page. Boom, boom. Ta-da. All right, so we're just going to look at this top diagram right here. Don't worry about the bottom. So just look at the top. So let's 6 and 7, angle 6, angle 7. Want to try to figure out how can we describe angle 6 and 7. So angle 6 is right here. And angle 7 right here. So we have a couple options on what could the relationship between angle 6 and 7 be. There's a couple possible options. So if we look at diagrams on the front page, so if we look at the diagrams on the front page, that might help us. Linear pair, that's a good start. Yup. Most indeed a linear pair. Yep, because they have they share a side. Good. I'll give you that. That's a good start there, Amy. Good.
It could be
Adjacent? Yes, Brooklyn. I agree with that too. They're adjacent angles. The linear pair. Adjacent. Because they share a side. Okay, I like that. Now, if they're a linear pair, they must also be not vertical. Not a bad guess, though, but they're not. One other thing, it was right, very close to where. Which means they are. Not all the time. Sometimes they could. They're going to be supplementary. Yes. Now, let's say, so Brooklyn, let's say if they both form 90 degrees, then they could be congruent. So that's why I don't want to like say, nah, you were correct. In some cases, you could have been correct because if 6 and 7 were both 90 degrees, then you would have had a correct answer. So we don't know, but it could happen. We never know. So, but they're definitely supplementary. So they're supplementary angles. Good. All right, I'll just put it right here. And if they're supplementary angles, that means they add up to how many degrees? Yep, that's it. They add up to 180. Very good. And I just want us to be familiar with the terminology. Because that's the goal. If we're familiar with, okay, these two angles are supplementary, then you know exactly how many degrees they add up to be. There's going to be no ambiguity, no ifs, ands, or buts about it. So, good start. All right, now let's look at 9 and 7. Here's 9, and here's 7. They're vertical angles. That's right, Brooklyn. Good drop. 9 and 7 are vertical angles. So that means how many what do we know about the relationship of vertical angles? Begins with a C. Not all the time. Congruent. They're right across from each other. If they're right across from each other, they're congruent. Because they're across from each other. So they're congruent. So what's meant by the word congruent? It means they have the, begins with an S. Same what? Close. Same angle begins with an M. Same angle measure. Okay. Same angle measure. Questions? These are definitely going to be things to know down the road. So I say complementary. They add up to 90. Supplementary add up to 180. Vertical, congruent. That means same angle measure. So these are just definitely things to think about as we proceed, not only for the unit, but throughout the year. Questions? Okay. So now what we're going to do, we're going to use this idea of linear pair, same measurement, because that's going to help us complete this activity down here, along with what we talked about on the earlier page. Now, a couple things I'm going to tell you. Thing number one I'm going to tell you. Well, actually, we're not going to do this part in order. We're going to go backwards. This part right here, we're going to go a little backwards with this. Now, name a set. When we name a set, we're going to use 3 letters. 3 letters. Three letters. And remember, the middle letter is a turning point.
Isn't that the main factor?
Not all the time. Sometimes it might be. But okay, in this case it will be. Not all the time, but in this case it's going to be that middle letter because everything's going to meet at that one point. So here it will be. So that's a good question now. I see where you're going. Now sometimes it might. Sometimes that might be, boom, right in the middle. And in this case, that could happen. And I'm going to show you why that might happen. All right. 3 letters, middle letter is the turning point. And in all these cases, there's going to be a turning point for each and every one of our angles. It's going to be the F. Point F is going to be the middle letter. Not all the time, but this case it will be. This example, F is 3/3. So every single one of our angles is going to have the letter F in the middle. All right, here we go. So what we're going to do, this is why we're going to do this in out of order. Because notice we don't know all the angle measures. We only have 1, 2, 3 angle measures, right? Is that what we see? However, we do know what this angle measure is right here. Because let's pretend this line didn't exist. What do we know about the relationship between AFE? Okay. And what about CFD?
It doesn't have a degree.
It doesn't, but
The DFE.
okay, DFE has a degree. All right. But can we still, given this information, get this angle right here, CFD?
Yeah.
What can we do? Well, we have 2 options. One option, I'm going to highlight. If I highlight this line right here, right there. What does this line form? Okay, heads up. Everybody else should have their heads up. This is not sleepy time. This is still class. I know it's Friday afternoon, but we're still in class. What? Okay, it equals 180. So this angle plus this angle has to add up to 180. Sorry about that. So this angle plus this angle, whatever this is, we'll just put a blank here, adds up to 180. So we have 118 over here. You could put X there, that's fine.
Oh, I think it would be 118 plus 70 equals 180.
Okay, careful. So let's check. You're close.
70.
So, well, what could we do to the 180 and the 118? Do the subtraction. So let's subtract 180 minus 118. Let's see what we get. All right, do we agree, disagree? All right, I haven't seen everybody. Let's open up them calculators. I don't know why they're closed. Okay, let's open our calculator. We need to open those calculators because,
It's 62.
so 180 minus 118 is 62?
So the degree to that equals 62.
It's going to be 62. This one's going to be 62 right here. Yes. Let me make that 6 a little bigger. So yeah, this is going to be 62. So 118 plus 62 equals 180. So this angle CFD will also be 62. So that's going to be hint number 1. Now, this other part right here, we're going to have to do a little work to get this last little piece. But it can be done.
Doesn't it have to equal 90?
Who has to equal 90?
AFE.
How'd you get that? How'd you get 90? Talk to me. Talk to us.
Because it's a right angle. It's a right angle, yeah. Just shifted.
But why would it be a right
If
angle?
one side's 180, the other one's 90.
All right.
But I guess it wouldn't be 90, considering if one side is 90, wouldn't that mean the other side would have to be 90 as well?
In the end, it would be. So you two are right. So that AFB is indeed going to be 90. So that's exactly correct. That's very good thinking. I like that. Because this side right here, 28 plus 62 is 90. This other side has to be 90. And again, this is why I'm going to tell you all, even though this line looks crooked,
62 plus 28 equals 90.
right? So this part is 90, that part's also 90. Very good thinking there. I'm happy. I am liking this. Well done. All righty. Good job there. Questions? So that's going to help us now answer all of these questions down here. And again, this is what we're going to have to do. We're going to have to take the clues. All right, Richard. Let's keep that head up, buddy. Take the clues from the diagram, and that's going to help us get answers to other parts. Now we have enough information to answer every question here. So, complementary angles.
That would be like that would be line, like downward line. That would be 118 and then 62.
Okay, so let's be careful. You gave us something else, though. The 118 and the 62, that adds up to one number. So that means, are they complementary or are they supplementary? So supplementary, they do have a relationship. They add up to 180, and so they're supplementary. Good. Now, going back to what you said, Amy, I like how you used the letter names. So angle EFD and angle EFA. I liked how you're starting to use letters as your angle names. Good. So that's an example. They add up to 180. Is there any other pair of angles we can use? We can use EFD. Angle EFD. And what other angle besides EFD can we use? Close.
No,
FCD. There we go. FCD. Good. So those are examples of supplementary. They add up to 180. Now, really quick with complementary, I think there's only going to be one, maybe two possible options for this. CFD could be one of them. So, but what do complementary angles add up to be? 90. 90 degrees. So, Brooklyn, you said CFD, right? Okay, I'm going to give you that part. And who else besides CFD makes this work? Close. B and F I'll give you.
It would be BFD.
Remember, BF, that gives you the grand total.
Yeah.
So, well, what line? So it's going to be BF something. BF. Remember, that gives you the grand total.
BFA.
Yeah, E. No.
EFC. There you go, Richard. So you said that too, Nelson? One of you guys said it, but I know, Richard, you definitely said it. Yeah. CFD is 62. BFC is 28. That's where we get the that's where we get the
Okay, yeah,
relationship.
it needs to add up to 90, okay.
Yeah, you gave me the overall grand total.
Yeah.
But that's all right. Hey, that's okay. You were in the area. You had the right idea. Because we needed that BF line for something. And then in the end, you got the BFC. So BFD gave us the grand total, which is good because down the road, you're going to see a problem like that. Grand total is 90. You got to give me each part. So that's good. All right. And I think the other example, BFC, and I'll let you look at that one at home. Angle BFC.
For supplementary angles, you put FCD.
Oh, you're right. I mean CFD. Yep. I got to change that up. Very good. Yep. Good catch. Yep, because F had to be in the middle every time. You're right. Good job. Okay. Now, with adjacent angles, you can use actually the examples from here. So those are some examples. So these two you could use in here as well. Remember, adjacent angles, they share a side. Now, supplementary angles could be an example. Now, are there any other angles that may share a side?
Isn't AFC?
That's your grand total. Okay, well, where are we going with AFC? All right, let's talk about that. Where are you going with this? But you're not.
Because what's it called? The angle bisect is going up. It's in the middle of AFC.
Okay. All right. I just want to make sure I don't want to. Just want to make sure where we're going with this. I'm not saying incorrect, correct, or anything like that. Okay, so I just want to make sure I'm getting you right. So which angles? What was your first angle again, Brooklyn? Okay, AFC. All right, that's not bad. Let's see where we're going with this. Angle AFC. So we have AFC. So now remember, they have to share a side. So AFC, you could also have, so if we go from C to F, then which way from F can we go? Oh, okay, you know what? That's not wrong.
D?
You can go either one. Yeah, you can go to E or you can go to D. So you would both be right because they're both sharing the side, AF, or CF. AFC and CFD. I'll just write angles AFC, CFD. Also, if you said angles AFC and AFE, they both work too. Because in the end, the key is with the share aside, how many letters must you see for both angles? At least how many letters need to be the same in both angles? So if you look at the first one, AFC, CFD, which two letters do we see in both cases? C and F, right? And then for the bottom one, AF, AF. That's how you can tell. Two letters must be common. So that's a good point. So share a side. So 2 common letters. That's one way you can get it. 2 common letters. So, and in both cases here, you had EF, EF, or FD and FD. Questions? Oh, do you have a question? Oh, yeah, you hand up. All right, now, we're almost done. Okay, for number 4, I'm going to make this a little smaller. No. Okay, linear pair. I'll give you a hint. They have to add up to what number? 180. So basically, CFD and who else?
AFE.
Careful. AFE and CFD are going to go here.
It wouldn't be AFC too.
AFC would work with CFD. You're right. That would work. So angles AFC and CFD. And then for vertical, you gave me a vertical pair, Amy. That's all right. So, have your agenda ready? So AFE and CFD. So that's an example of verticals. And then also, for supplementary, you can put these guys for number 4 as well. Okay, questions? Any questions? All right, so what we're going to do, we're going to use these ideas for when we do some of these other problems on the other page, on the next page. All right, so should be able to get most of these before the bell.
So would it be something like this one?
It's going to be some like that, but it's also going to be stuff from before, like the last, like not only today, but from the previous. Yeah, it's going to be a mixture of the two. And then, so it's going to be a mixture of what we did, what we're doing today, along with what we did last time. And then there's just some general terms. So my goal is we talk about that before the period's over. All right, so here we go. All right, let's look at this first one. Okay, heads up, everybody, get ready. Cindy, you too. Head up. All right, let's look at this diagram right here. First off, we need to ask ourselves the relationship. What type of angles do we have here? They're vertical. So that's step number 1, because that's going to help us. Vertical angles. That means, what do we know about the relationship between these two angles? If they're vertical, that means they are the same. There you go. You're right. Richard's right. They're the same.
Can we solve that?
So you're going to get the value of x. So the way you're going to get the value of x, because Richard said the two angles are the same, right? So here's our setup. X plus 16 equals, oops, two pluses, 4x minus 5. That's going to be your setup equation. Now, are we at a point where we can solve for the x? Yeah, agree. So who could tell us our first step to solve for x in this problem? What do we do first?
Oh, add x. So minus it.
Minus x, exactly. Very good, minus x. Good job. I like how you're going to minus x. Now, we have 16 equals, well, what's 4x minus x? Yes. Uh-huh. And then minus 5. Now, what's our next step here? Yes. Add 5. So we're going to be solving these types of equations in and out all year. So we add 5. So now the 5s go away. So then we have, what's 16 plus 5? And that equals how many x? The x. All right. Now, what's our last step to solve for the x? By? Yes. Very good, Nelson. Very good. Very good, Amy. And then what is x? 7 equals x. All right. Now, what do we do to get the angle measure?
So now we substitute the 7 to x.
Yup. So then we substitute 7. Oops, let me not write it like that. So it'll be just 7 plus 16, which is, yeah, 7 plus 16. Yeah, I don't think I have enough room, but you know what? Let me get this. Oh, no.
In our other class, we did it a different way. We didn't add 7 plus 16. We did it a different way.
Okay. How so?
I forgot how, but we didn't add it. I think we multiplied them.
So there will be some multiplying.
For example, where it says 4x, that would be 4 times
Oh,
7.
yeah, because maybe we just put the x in by itself.
That's why. Yeah.
We didn't have an x by itself, so that's why I was thinking.
When x is close to 4, that means that it's multiplying.
Uh, But that's okay. But I'm glad we're talking about this. No, this is good thinking. That's very good. Now, but I see where so this case, just add them up. But the next one,
That would equal 23.
but I see where you're going. But I see what you're saying too. Yeah, so both cases, that number should be what number? So you're going to get 23 in both cases. That's what I'm worried about the most. Yeah, I know it's a little tight here. So 23, and then 4 times 7 minus 5 is also 23. So you should get 23. All right, that's good, because in the end, they were both the same, right? So yeah, you get 23 in both cases. So yeah, x is 7, boom, 23. Boom, 23. All right. So that's the most important part. You got the same value for both angles. Okay, let's look at the second one. Just gonna put a line to separate. That's special for anybody who was absent.
Is that a agent?
Which type are they?
I don't know if that.
Okay,
To,
they're I mean, you're right, they are adjacent because they have the same side. But what else? Okay, I'm not gonna, you're right on that part. And then what else do we have? They're a linear pair. Good. Yeah, adjacent, you were right. Brooklyn, you're right because they have the same side. And in this case, they were a linear pair. So that's a linear pair right there. And again, I like the participation. And what do we know about the linear pair? They share the same side. What else? There's something else. Supplementary. That means they add up to what? 180. So linear pair add up to 180. So then what do we know? So then what must the sum of these two angles add up to be? 180. So we'll set up our equation. So you're going to take your first angle. Take the 5x minus 18.
yeah, I was gonna say, like, since you're, question one, you're equal to some here, like, side you have to add up to.
When you combine like terms for 5 and 4 and then give you 9x.
Exactly. Good job. Combine those like terms. Exactly, Brooklyn. Besides a 5x and a 4x, what else are we going to combine? Yup. You got to combine these guys. Good. But I like how right away you said we have to combine like. So then we have an 18, oh, we have a negative 18 and a positive 45. So think about it like you're buying something for $18. You have 45 in your pocket. How much would you have remaining? 27.
So you're gonna minus 27.
Good. That's next step. Very good. Minus 27.
It's gonna be 153.
And 9x is going to be 153. 27's knock each other out.
So you're gonna divide 9 to both sides.
9x.
It's gonna give you 17.
53. Exactly. Divide by 9. And then you're going to get x is 17. Good. All right, I'm going to make some space so I don't. Okay, so we have x is 17. So now for the final two. So now we're going to play. So it's going to be 4 times 17.
113.
Yup. Because you're going to get 68 plus 45. 113. Very good. Because Brooklyn did 4 times 17 plus 45. Try to sneak it in there. I know there wasn't a whole lot of space.
And 5x minus 18 is equal to 67, and 113 plus 67 is equal to
That's exactly right. Well done. And I liked how you checked your work. 113 plus 67 gives you a grand total of 180.
The 4x one, I got 70 something, and I did my work. And I got my
All right, but that's exactly what you have to do. You weren't sure, you did it again, and then you realize, okay, that's what I'm supposed to have.
So you didn't get the right one because you gave me 140.
Yeah. No, and that's good. That's good checking. That's exactly what you need to do. Well done. So I apologize, it's a little bunch there, but that's exactly what you need to do. You said, oh, I don't like my answer. I want to try it again. And then, voila, we have a correct answer. Very good work. Okay, questions on these first two problems? Okay, next two is going to be a little more work, but they're not so bad. They're going to be kind of like, well, no, I definitely want to do number 3, and then number 4, I'll just do the setup, because number 4, once you set it up, it's going to be just like number 2. All right. So number 3, angle A and angle B are complementary. So what does that mean? If angle A and angle B are complementary, that means they must add up to how many degrees? They're adding up to 90 degrees. So the measurement of angle A, measurement, angle B, is 90. So complementary, that means the sum is 90. Very good. That's okay. But what did we say angle A is going to be? What expression?
5x plus 8.
So we're going to have a 5x plus 8. You're going to replace angle A with 5x plus 8 plus x plus 4. And what must this sum up?
Equals 90.
Yup. All right. Are we at a point? Combine like terms.
5x plus 1 is x into the 1, so it'll be 6x.
6x it is. Very good. Yup. 6x plus. And what does that all equal?
Not 2.
90.
Oh,
Okay.
I'm dividing that.
Okay, yeah, you gotta be careful.
Yeah.
So, but so far so good. The setup is good. I'm liking this.
Minus the 12 and 90.
So I'll have you all. I want you all to try the rest of this one real quick. Definitely get the x. So you're gonna minus 12. Actually, we'll do this. Okay, so the 12s knock each other out. And then 90 minus 12 gives us what number? So 6x is 78. And what are we gonna get for x? 13. Yes, good job. All right, so we have x is 13. Okay, so now we're going to take angle A was what expression again? 5x plus 8. And then just like before, plug it in. And then similarly, x plus, I want you all to try those real quick. Plug it in, see what we get. I'm going to give you all, let you do that real quick. Angle A is going to be 73 because you have 5 times 13 plus 8, 73. Good job. And then with angle B, so angle A is 73. All right, so 13 plus 4. 17, very good. So angle A is 73. Here's what I'm going to do. I'm going to highlight this part right here. That's, and then your other one, 13 plus 4, which equals 17. And what happens when we add 73 and 17? What should we get? Yeah, that's exactly what we want. Well done. Okay, questions on that problem? That was really good. Again, I'm going to come around making sure everybody understands that setup here. Making sure we got the setup, we understand. If not sure, you need to say something. I'll leave it up for a moment. All right. Now, really quick, we're just going to talk about the setup for the 4. Supplementary. Add up to 180. So angle A. Okay, so oops. So you said 12x plus 1. Okay, what else? That's your setup for this problem. Very good. Yup. So angle 1 or angle A plus angle B equals 180 because they're supplementary. Yes. Excellent.
Don't you do 1 plus 10?
Yes. Yes. Careful. So you're going to subtract. Okay. All right. I see where we're going with this.
Oh, that's 169.
Yep, so 13x is going to be 169. And then x will be 13. Very good. Because in the end, you're going to divide both sides by 13. Yep. That's right. X will be 13. So remember, angle A, 12x plus 1.
A equals 157.
All right, yup. I see where you got that because 12x plus 1. And then that's going to be,
And then B is going to be 23.
yup, x plus 10.
And that gives you 180.
Yes, it will. Very good. Well done. All right, I'm impressed. That's good work. I'll leave this up for a minute. Goes 157. And then 13 plus 10 equals 23. That's angle A and B in a nutshell. Again, this is, I just want to separate angle A and then angle B. Okay. Questions? We okay with this? Richard? You got this right? Okay. I think starting soon, I'm going to come around. Not today, but soon. I'm going to start coming around and seeing if you did your notes, you get credit. If you don't do your notes, you're not going to get credit. So I might, not today, but down the road. All right. Let's look at the backside real quick. Doing really well. All right. So the last things I want to talk about. Angle bisectors. This is going to be important. So what did we say about angle bisectors? The angle bisector did what to the big angle? Any?
Cuts it in half.
Cuts it directly in half. So if this side is 22, what must this side also be? Good. All right, so right away, so measure of angle PQS. There's P. We go from P.
PQS is like 24.
Yeah, it will be 22. Boom, that's going to be 22.
QR is 44 then.
How'd you get 44?
You add the three there.
That's exactly what you do. Because the reason being PQR was the entire angle. It's the entire angle from here all the way over. So PQR is 44, whereas PQS 22. Exactly. On your quiz and definitely on your test, you're going to get something exactly like this one and the next one. All right. Now the next one, similar idea.
They're both 60 degrees.
Okay, this guy's going to be 60.
So it'll be 112.
Close, 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 close. It's going to be one something. 120. All right, I'm going to type it in. This one's going to be 120. So you're going to have 60 for the top. UTV is also going to be 60 because, and that's why highlighters or in colored pencils are going to be important going forward. There's UTV. Boom. Boom. You just think about it like a road map. You start at U.
And then
See?
the S is 120.
Yes. Exactly, Brooklyn. Well done. Overall big angle. 120 degrees. All right. Good job. So far, so good. Any questions? All right.
This is basically the last one, basically what we did in the other questions, but just put in a different like wording.
Yeah. Oh, exactly. All right, this last one. This one we're going to have to do a little work. But it's going to be based on our previous two. So, BD, this line right here. Angle bisector. What do we know about these two angles then? They have to be not add up to 180, but angle bisector did what? It split it in half. So what do we know about the measurement of these two angles? If it's in half, that means the two angles they're the same. Yeah. So for this last one, your setup is going to be the following. Since BD's a bisector, you have to set x plus 15 to equal 4x minus 45. That's going to be your setup. Because ABD, I'll write it, actually I'm going to write it above. Angle ABD equals angle DBC. Yep. So you're gonna come. Oh, be careful. Remember, are they on the same side or are they on opposite side? Yeah. That's okay. But you're gonna do some minusing.
It would be negative 5 because you're subtracting 1 from 4. No, it would be negative 3.
Well, we're gonna do okay. So which term did we move? Did we move x or the 4x? Okay, so it's gonna be 4 minus 1.
Negative 3.
Well, what's 4 minus 1 is just 3x, but you're on the right track. So 3x minus 45. Well, we have 15.
You divide 3 by negative, no,
Add 45. You gotta add 45, yeah.
and that would give you 60.
You're gonna get 3x is 60, yes. So 3x, so 60 is gonna be 3x. I know it's a little messy.
It would give you
Sorry, it's gonna be a little messy. It's gonna be 20. X is 20. Exactly. And then what you're gonna do, now it's a little wonky because this was kind of out of order. So DBC was your 4x minus 45, so it would be 4 times 20 minus 45. But if you do that, what would we get? Okay, you get 35 for DBC. So if this guy's 35, then what must ABD also be? 35 as well. And then,
It's the end of the week, Herman. Don't forget tonight's big game at South Lakes
And then
football, 7 p.m.
what would be the grand total?
Cheer for the Hornets. We expect great sportsmanship and your best behavior. Be safe. Have a great weekend.
All right, so perfect timing. So yeah, ABC would be the grand total between the two. All right, here's what we're gonna do. I'm gonna give out this assignment. It's gonna be based on. You might see my notes in school with you. If you're
I had some of my old notes from the last time.
okay, and then if you have access to the Schoology class, anything else, you can look at previous stuff, and then we'll talk more next class. Here is, so this is gonna be last assignment for homework assignment. I'm not gonna give you one next time, but this is gonna help you for your quiz next Thursday. So remember, you have a quiz next Thursday. So your quiz is next Thursday. It's going to be based on what we have going on here. Anybody have any final questions for me before we wrap this up? All right. So you all did a great job today.